This video covers reading in raw data to R. So what are we trying to do in this course? Well, we're trying to do things with data. And so one of the things that we need to be able to do is, of course, bring in data from an external source into R. And so oftentimes we refer to data that is not in our programming language, so it's not already stored somewhere in our language, as raw data. And so what we're going to do in this video is look at how do I read in raw data in commonly used source types. And so we need to know about those formats, the types of files that we often store data in. Well, one of the most common ways to store data is just as delimited data. So for instance, you might use a comma as a delimiter. A delimiter is just a character or value that separates entries of your data. And so I'm going to open the CSV file in Notepad. By default, most CSV files are going to try to open in Excel, and that doesn't allow you to see the comma separated value file structure. It just looks like an Excel spreadsheet. So again, I'm going to open this CSV file in Notepad or something similar. And you can see what we mean by a comma separated value file or using a comma as a delimiter. Here is my first variable name, and then I have a comma, the second variable name, a comma, the third. So the comma is acting as what we call a delimiter, a value that separates entries in my raw data. And so here's the first line of actual data. And again, you can see I have 1 for week 1, and then I have a comma, and then the date comes after that. So these commas are, again, what are separating the actual data entries themselves. Really, any character value can be used as a delimiter. So you might have something that's like a greater than delimited data set. So here I have my entries, a greater than sign representing that now I have my next entry, greater than sign representing that I have my next entry. Another very commonly used delimiter is a space, and then there's also tabs that are used quite a bit as well. So we'll learn how to read in delimited data. Data also comes in the form of what's called fixed field data. So fixed field data just means that, for instance, brand always starts in the first column of my sort of raw data. Tar always starts in this column, and nicotine always in this column. So there is actually a very set number of spaces to get over to tar. And essentially we can tell our programming language how much space to use for the first variable, the second, the third, and so on. So again, this is fixed width or fixed field data. Of course, data is often stored in an Excel spreadsheet, so we'll look at how to read that in as well. And then later on, we'll look at reading data from a database and application programming interface, or API. Now, one of the things about R is that there are usually a million ways to do the same thing. And so we have to think about realistically, what do we want? How do we want to read in the data? Well, possible methods would be base R methods. Base R methods are fine. Remember, base R is what comes pre-installed with R. The functions to read in delimited data from base R are reasonable, but some of their default behavior is a little bit funky, and they're not necessarily as fast as we want them to be computationally. And so instead, we've looked at this tidyverse a bit. And so what we can do is use the functions from the tidyverse. They're going to be perfect for working with these other functions we've already done for dealing with manipulating data and plotting. And so if we use these tidyverse functions, everything should play nice together. Good news, if you've already installed the tidyverse, you have access to a package within that will allow us to read in a lot of these types of data. So in your R session, you should do library tidyverse. This will give you access to the readr package. And once you have access to the readr package, we can look at functions that will read in basic delimited data. So we'll look at read underscore CSV. Remember, CSV stands for comma separated value file. So comma as our delimiter. So let's jump into R. I've already done read underscore CSV here, and you can see it pops up this for my help file. And basically there are 3 very commonly used read underscore functions for dealing with delimited data. CSV for comma separated values, TSV for tab separated, and then read underscore delim is just a sort of generic function that allows you to specify what you'd want that delimiter to be. So how do we use these functions? Well, oftentimes it helps just to look at how the function is written, sort of in its base call. And remember that any of these arguments that have an equal sign with a value after them have a default set to them. So for instance, call names has a default value of being true, call types has a default value of null, and so on. And so the only things that we really absolutely have to specify when we call read_CSV are things that do not have a default value. So the only thing that does not have a default value is file. And so what does file represent? Well, this is either a path to a file, a connection, or a literal data. So most often this is going to be a path to a file. And so what we need to be able to do is explain to R how to find a file on our computer. So that's what we'll talk about next. Well, so files are stored generally in folders on your computer. So for instance, if you say were to open up say a file explorer browser in Windows, you have a whole folder structure. Within your C drive, for instance, there's a folder called program files, et cetera, et cetera. So for me, I have folders where I end up storing all of my things. Let's see, documents, repos. So all the way within this folder, I now have a folder with data sets in it. Okay. So this right here represents the path to that folder. And so the path to this particular file, say I wanted to read in umps2012.txt, I would need to know this full path name plus the file name. And that's what I would use to tell R exactly where this file is located. And it's very similar on a Mac as well. So, like I said, generally speaking, your path name is just a series of folders nested within one another. So I might say that this is my folder right here that I have data sets stored in. And notice that I'm using this the forward slash here. Whenever you look at it in this format, it does not use that forward slash, it uses a backslash. But backslashes in R are what are called escape characters. And so they sort of are used to denote that something special is coming next. And so if I want to use a backslash in R, I actually need to put 2 backslashes. So both of these are equivalent ways to define a path to this datasets folder. Okay, so oftentimes you don't really want to specify the full path because, as you can see, that would be a lot of typing. So what you can do generally is change your what's called working directory. So your working directory is where your computer is already looking, where your R session is already looking for files. So for instance, right now I ran git wd, so this is git working directory, and this says that the path to the folder that my R session is currently looking in is this reading data folder. And so what this would allow you to do is if I had my data sets within here, rather than giving the full path to the data set, I could just give scores.csv or umps2012.txt, and R would know exactly how to find that file. And so sometimes what we want to do is just change our working directory to make our lives easier. And I would recommend doing this via code because it's more reproducible. So I might change my working directory by using setwd, set working directory. And now I need to give it a quoted string for the path to whatever folder I want to set. So here I'm setting it to my base ST308 folder. Again, if you want to use backslashes, you need to do a double because R interprets one single backslash as a special escape character. Alternatively, you can change your working directory via menus. I don't really recommend that, but works perfectly fine. Okay, so while we're talking about working directories and things, we should just talk about this really nice feature of RStudio called a project. And so what comes up a lot of the times is that you'll end up having a lot of files associated with one single project. And so if you have 2 projects that you're working on at once, so maybe I'm doing an analysis for corn yield and I'm also doing an analysis for hockey data, every time I open R, I don't want to have to reset everything so that I can tell R exactly how to deal with my hockey project versus my corn yield project. And so what you can do is use this project feature in RStudio to sort of make your life easy. What the project does is it gives us a straightforward way to sort of keep a working directory consistent, a workspace, a history, and all your source documents consistent across a particular project. And it's really easy to create. You just go to File, New Project, and you can do it from an existing or new directory. And that's what I do for my courses here. So I'm currently in my ST308 project. That's actually what this little button up here says. This is a ST308 project. And so if I wanted to switch to, say, ST501, I can jump over there. It opens up a new R session here. Notice that my working space has now changed to here. Up here, we've changed to ST501. And now all the files that I see up here are related to ST501. But if I want to then go back and work on ST308, I click back on there. And it allows me to pick up exactly where I left off when I was working before. So it kept all my files open. If I had changed my working directory, it changed where that was. It kept my help file up. If I had plots, it would keep those. So again, this is just a really nice way to separate your different undertakings. So I'd recommend you take and create one for today's lesson, or maybe for the course at least. All right, back to what we're trying to do, right? We're trying to read in some raw data. And so we now know what a comma separated value file is. We know that if we read in the tidyverse, we get access to readr package, which allows us to use the read_csv function. We know that we now have paths, and we know how to specify those to find the files. And so we're ready to go. We want to read in the scores.csv file. We can either download the files, put them on our computer, and point to that path. Or what's nice is if you have an internet connection, you can pull straight from the web. So I'm going to pull straight from the web. I'm going to use read_csv and specify that the path to my file is actually just this URL. Notice I'm giving it fully to scores.csv. So I'm giving it the full path to that exact file. And I'm storing that in an object called score data. We check out what score data looks like. It appears as though that data set read in correctly. Hooray. And it's really that easy because these functions have really nice default settings. So you might notice this fancy printing. So we've talked about tibbles before. So since readr is a package within the tidyverse, whenever you read in a data set with a readr function, it will read it in as a tibble, generally speaking. And these are great because they print out more nicely, but essentially they are just a special case of a data frame. Remember that a data frame is just a two-dimensional object that has possibly different types of columns. So you might ask yourself, how did R determine the column types? If I go back and look at this, it has integer here, character here, let's see, time here, and so forth. Well, what R does is to determine the column types, it scans the first bunch of rows. So you might see here, there's a, let's see, read_csv. There's a call types argument that we can specify. We didn't, so we use the default of null. So let's see what happens with that. So one of these, if null, all column types will be imputed from the first 1,000 rows on the input. So essentially, R looked at the file, looked at the first 1,000 rows and said, well, what is the least restrictive data type that is available within that particular column? And then it set that as the column type. So again, really fantastic default settings from these tidyverse functions. All right, and just to note, oftentimes you read in the data, you want to do a data validation at some point in time. And so a very basic way to do data validation is just to look at the column type. So here I have a different data set that's sort of a smaller version of that has a typo in it. And you might look at this season variable and see that it's stored as a character variable. And you might say, well, it shouldn't be because season is always, a number. Well, it turns out that there was a typo here. And so that gives me a way to know, like, oh, there's some sort of data issue here that I should go and try to remedy. So a very basic data validation step is just looking at what type of columns you have read in. Okay, so again, we're using the tidyverse method for reading in CSV. We should talk about the base R method because a lot of people forget that we're using read_CSV. We'll Google it and we'll end up using read.csv. Read.csv is a base R method. Generally speaking, the dots correspond to base R methods and underscores will correspond to tidyverse methods. But what this does by default, which can be good or bad, is it reads character variables as what are called factors. What is a factor? It's something that you're going to come across as you program in R, and sometimes they're going to be a real pain. They are essentially a special version of a character vector where you can only take on a certain set number of values. or what you might refer to as levels. So these are really great variables whenever you have something like day or week. So day could be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday. Those are all of the values that day will ever take on. And since those are all the values that day will ever take on, treating day as a factor makes perfect sense. What dealing with a character vector as a factor allows you to do is reorder the sort of default ordering of the values of the levels. So for instance, if I took the score data $day column and I coerced it to a factor, so I'm doing as.factor to do explicit coercion, and I'm overwriting that column, I now have a levels attribute that says that these are the possible values that this variable can take on. And these are the only possible values this variable can take on. And so, again, what this allows me to do is if I did a basic plot of, say, the away final score, after removing a couple of days that don't have very many games, this would be the default ordering. And you can see that this is alphabetical, MSST. But that's not the ordering that I necessarily want to have, right? That's not the chronological order of days. And so what you can do with levels is you can reorder the levels. And then basically when you do your plots or your summaries, they'll come out in the right order for what makes sense. So here I'm using the ordered function to take in that column. And I'm saying that the levels should start on Wednesday and go to Tuesday. And I'm overwriting that variable within the data set. And now when I look at the levels, again, a special attribute of that column, they are now in the order specified up there. So if I make the same plot, now Thursday will come before Saturday, which will come before Sunday and Monday. So factors can be really useful if you have a character variable that only takes on a set number of levels. But having that as the default behavior is really not the best thing. And so the tidyverse does not have factors as default behavior. Base-R methods does. Okay, so I think this is a good point to sort of recalibrate ourselves, right? We are learning how to read in this raw data. Currently, we're on delimited data, and we're using the readr package to read it in. We've seen how to use read_CSV. We'll use read_delim in a minute. And then we'll talk about reading in Excel data as well. For those of you that have programmed in other languages, I do want to let you know that there are functions and packages for reading in, say, a SAS dataset or an SPSS dataset. We won't cover those here, but it's pretty straightforward. All right, so let's do another example of reading in raw data. Recall that we have this umps.txt file. And so this has greater than delimiters for it. Notice that there are no column names provided in this data set, right? This is the top row, and there's no column names above that. So we'll have to specify those. The column names themselves are given here. And so we want to use read_delim. We can't use read_CSV because this is not a comma-separated value file, but this is a more generic delimited file. So we need to go into the help for that. So here's read_delim. It has two arguments that do not have default function values. File, so we need to give it the path to the file, and delim, or the delimiter. So there's where we can specify a single character to be used to separate fields within a record. So we'll give it the quoted string of a greater than sign. Beyond that, again, we don't have column names within our data set, so call names equal true is not what we want to have. So call names is either true, false, or a character vector of column names. So essentially, we'll just need to specify the character vector of column names when we read this in. Okay. So here would be a line of code that would allow us to read this in. Read_delim, I'm giving the path to the file. Again, here I'm pulling from the web. I'm specifying that the delimiter is a greater than sign, and then that the column names are given by this character vector. I'm storing the results of that in ump data. So whenever I go to print ump data out to the console, it's a special data frame, this tibble, and it has nice printing properties, and we can see basically that it looks like things are good here. Year is an integer, month integer, day integer, home, away, and umpire are all character. So that all makes sense. A very basic data validation step taken care of. So again, reading in any kind of delimited file, basically you can use a function from readr. There are some commonly used ones: CSV, TSV, table for spaces. CSV2 is for a semicolon. Semicolons are widely used in Europe instead of commas. That's because they use commas for decimal points for like numbers and things over there. Sorry, money and things like that over there. All right. So what else are we going to read in? Well, we talked about fixed field data and Excel data. So how do I do a fixed field data? Remember, fixed field just means that all of the data entries start on at the same point in the file. Well, we're going to use read underscore FWF for fixed width field. And basically what we need to do is specify the column positions to that function. We're going to give it, again, the path to the file. And then we don't need to actually explicitly point out where the data lies. We can use this FWF underscore empty function to sort of try to figure it out on its own. That function actually takes in that same path to that file, and then you need to give it the column names from there. That's pretty much it. So we're going to give it the path to the file, and then something that tells it where the data exists, so the column positions. If we do that, things look almost right. So I do have brand here, Alpine, tar, but this first row is actually the values from the data set. So that's not what we want. What we need to do here is add in the optional argument of skip equal 1. And so skip equal 1 just says skip that first line, that first row of data within the raw data and start on the second line. We do that and things look great. We're now seeing doubles for our variable types here and character there. Optionally, if you happen to know the exact number of characters that each variable takes up, you can specify the column positions with this FWF underscore widths function. So this says that the first variable takes up 17 character values. So there's 5, 10, 15, 16, 17 comes to right there. Then the next one takes up 5. So 1, 2, 3, 4, 5. The next one takes 9, 6. And then just to make sure that the last one takes up everything that's possibly left, you put an NA for that. And so this is a way to explicitly set the widths of the fields rather than having R try to figure it out on its own. Okay, if you do have trickier data than this, so maybe something with a bunch of issues in it, you can just read the entire file in as a string and then try to parse it from there. So you can use read underscore file or read underscore lines to try to do that. Generally speaking, this is a terrible process because you have to usually use what are called regular expressions to parse that data. And hopefully you can go through life without ever having to deal with those. Okay, so then let's get to our last big important type of data, and that's Excel data. So we have an Excel file here, censused.xls. or XLSX. There's 2 of them available on the web. And we can read those using the read underscore Excel function from the read Excel package. So while this does not come loaded with the tidyverse, it is a function written in the same sort of syntax as the tidyverse. So you will need to install this package if you haven't done it already. But once you've had that package read in, basically, it's the same kind of idea. We're going to use read underscore Excel, give it the path to the file, and then tell it which sheet to pull from. And so let me pull up this census ed file. And so the sheets, if you don't know what Excel sheets are, they are the things that you see across the bottom here. So this is the first sheet, the second sheet, third sheet. So each sheet might have different types of data within it. And so you can specify the path to the file and then which sheet you want to read in. One thing that kind of stinks about reading Excel files is that you cannot read them directly from the web. So this one you do need to download and put on your computer somewhere. And so if you remember that my working directory was this sort of ST308 plus 2 folders past that, this .. business says step down a folder. So this gets me out of my outermost folder, down even one more folder, and then I'm going up into datasets in censused.xlsx. So again, what's going on here is that I'm actually having my working directory for this markdown file that I've created in this folder. And I want to step down out of this folder and then out of this folder. So I'm using 2 .. to get down to this folder. And then I'm saying go up into datasets, and that's where the file exists. So I go up into datasets, and then that's where that file is. And then by default, it's going to read the first sheet, or you can specify that sheet by name. And there we go. If you want to just inspect the sheets without opening your Excel file, so maybe you don't have Excel on your computer, which happens a lot for Mac folks, you can look at the sheets that are available using the Excel_sheets function. You just give it the path to the file that you want, and then it'll tell you what sheets are named there. There are ways to read in only some of the columns within an Excel spreadsheet. And so this range option gives you a way to specify the columns. So for instance, if I want all the columns A through D, so if you open up Excel, right, it names its columns like A, B, C, D. So as long as you want columns that are sort of right next to each other, you can specify A:D and get all of those columns. And so there's lots of different options you can look at for reading in different column types. You can use a lot of the different sort of expression matching too. Okay, so now we know how to read in a lot of sort of basic raw data. Just to briefly mention it, sometimes we want to write out our data. And so usually, if we can, we just write to a CSV file. Remember, CSV is just comma separated value. If I have the readr package read in, I have access to write_CSV. And all I need to do for that is give it the object I want to write out. So here I'm writing out ed data and then a path that I want to write it out to. So here I'm saying the output from the working directory, the folder output, and then eddata.csv should be what is saved. Okay, so here's a little table to sort of summarize all of that. What we'll do next is look at reading data from databases and APIs.